Let's start now. Number 10. Terrestrial Planets, Rocky Worlds. The cosmic dust had not yet settled when primordial chaos finally gave way to a new order. In the frozen, silent vacuum of space, four spheres of rock and metal emerged from the sun's cradle of fire, forged not by delicacy, but by brutal collisions that would shape the fate of the entire solar system. If you were standing there at that precise moment, you would witness the birth of the only places in the galaxy where the universe would eventually learn to think. The terrestrial planets Mercury, Venus, Earth, and Mars are the solid jewels of our celestial neighborhood. Unlike the massive gas giants, which are immense expanses of hydrogen and helium with no firm ground to stand on, these rocky worlds possess a strictly defined structure, a dense metallic core, wrapped in a thick silicate mantle and a hardened outer crust. They are relatively small in physical scale, but they are giants in terms of geological complexity and chemical diversity. Mercury, the fleet-footed messenger, is a scorched desert of craters where time seems to have frozen, baking under relentless solar radiation. Right next door, Venus hides a literal hell beneath suffocating clouds of sulfuric acid. Its thick atmosphere creates a greenhouse effect so devastating that the atmospheric pressure would crush a heavy submarine in seconds. It serves as a grim, haunting reminder of how fragile planetary balance can truly be. In the ideal Goldilocks zone, we find Earth. Here, geology and biology dance together in perfect harmony. Liquid oceans and an oxygen-rich atmosphere allowed chemistry to transcend into life. Finally, there is Mars, the rusted wasteland. With its massive extinct volcanoes and bone-dry riverbeds, it holds the greatest mystery in modern astronomy. Was the red planet once a second Earth? These four worlds share a common origin but followed radically different paths. They are humanity's outposts in the infinite cosmos, the only grounds where our feet or our robots can truly stand and stare back at the stars. Number 9. Super-Earths. Imagine a world where the mountains are shorter, the air is thicker, and every step you take feels like you are carrying a lead vest on your shoulders. In the vast architecture of the galaxy, our own Earth is actually a bit of an underdog. The most common type of planet orbiting distant stars is one that our own solar system completely lacks: the super-Earth. These are the heavyweights of the rocky world category, massive terrestrial titans that bridge the gap between small planets like ours and the gas-shrouded giants like Neptune. A super-Earth is defined by its mass, typically ranging from 2 to 10 times that of our home world. Because of their immense size, they possess a powerful gravitational pull that can hold onto thick atmospheres, potentially shielding any life from the harsh radiation of their host stars. Some are scorched, barren rocks orbiting dangerously close to their suns, while others sit comfortably in the habitable zone, potentially hosting vast continents and deep, heavy oceans. The internal dynamics of these worlds are a source of great scientific wonder. With such high pressure at their centers, their metallic cores might behave in ways we can barely simulate in a lab, generating magnetic fields far stronger than Earth's. This magnetism is a crucial shield, protecting the atmosphere from being stripped away by stellar winds. For astronomers, super-Earths represent the ultimate what-if. If a planet has more surface area, more gravity to hold an atmosphere, and more internal heat to drive volcanic recycling, could it be even more hospitable to life than Earth itself? These massive cousins of our home world challenge our definitions of habitability, suggesting that the ideal cradle for life might not be a world our size, but something much, much larger. They are the sturdy foundations of the galaxy, waiting for us to uncover their secrets. Number 8. Mini-Neptunes. As we venture further away from the intense, scorching heat of the host stars, the clear-cut boundary between what we consider a rocky planet and what we define as a gaseous world begins to dissolve in a truly mysterious and ghostly way. It is here, in this cosmic transition zone, that we find the most enigmatic type of exoplanet, a class of celestial bodies that completely defies the simple, orderly categories of our own solar system. If you were to try and land your spacecraft on a mini-Neptune, the experience would not be a triumphant touchdown at all, but rather a never-ending, terrifying, and fatal fall into a bottomless abyss of crushing atmospheric pressure and searing internal heat. Mini-Neptunes are exactly what the name suggests to us, worlds that are physically smaller than our Neptune, but substantially larger and heavier than our Earth. However, their true alien nature resides in what they do not have: a solid, dependable surface to stand on. While a super-Earth is a massive rocky body that may or may not possess a thin atmosphere, a mini-Neptune is defined by its incredibly thick and impenetrable blanket of gases. They often possess rocky or icy cores at their very center, but these solid hearts are buried under thousands of miles of dense hydrogen and helium. The transition to a mini-Neptune occurs when a young protoplanet grows massive enough to magnetically capture the gas remaining from the star formation disk before it eventually disperses into the void. They are the near giants of the galaxy, caught in a state of permanent inflation. The pressure in these staggering depths is so overwhelming that gases can transition into exotic states, mixing with deep, boiling oceans of water, ammonia, or methane under physical conditions that simply do not exist anywhere on our home planet. For modern astronomers, these worlds are crucial because they mark the absolute limit of conventional habitability as we understand it. Without a solid surface and under such colossal atmospheric pressures, life as we know it is chemically and biologically impossible. Mini-Neptunes remain as silent, shrouded sentinels in the cosmic depths, reminding us that the most common planetary architecture in the galaxy is, paradoxically, the most alien and inhospitable to us. They are realms of perpetual mist and shadows, where the distinction between gas and liquid is lost forever in the total, crushing darkness. Number 7. Gas giants. Imagine a world so impossibly vast that it could easily contain more than 1,000 Earths inside of its belly, a sphere of such colossal proportions that its gravity alone commands the fate of hundreds of moons and thousands of wandering asteroids. However, despite all of its raw power and overwhelming volume, this world is essentially made of nothing more substantial than the very air we are breathing right now. The most terrifying and fascinating reality about the gas giants is that if you actually built a ship strong enough to survive its lethal radiation, you could fly straight through the planet without ever hitting a single piece of solid ground. Jupiter and Saturn, the undisputed kings of our own solar system, are the definitive examples of this majestic category. They are predominantly composed of hydrogen and helium, which are the exact same elements that fuel the stars themselves. They did not form through the slow and steady accumulation of rocks and dust, but rather through a rapid, violent gravitational collapse, greedily swallowing most of the material left over from the sun's formation. They are, in a very real sense, failed stars, worlds that simply failed to gain enough mass to ignite the fire of nuclear fusion. The internal structure of a gas giant is a realm where the laws of physics are pushed to the breaking point. As you descend deeper into their turbulent atmospheres, marked by anticyclonic storms that have raged for centuries, the pressure and temperature rise to unimaginable, hellish levels. Gaseous hydrogen is compressed until it becomes a thick liquid and, even deeper, transforms into liquid metallic hydrogen, an exotic state of matter that generates the most powerful and dangerous magnetic fields in the entire solar system. These planets are the true master sculptors of stellar systems. Their immense gravity migrates other planets into new orbits, clears away dangerous debris, and protects the inner rocky worlds from cataclysmic impacts. They are not just inert, floating masses of gas. They are dynamic, roaring engines of energy and cosmic influence. A gas giant is a demonstration of pure, unadulterated power, where classical physics is pushed to its absolute limit and where the very notion of a planet is redefined by a scale that feels truly impossible. Number 6. Ice giants. On the lonely outer edge of planetary systems, where the light from the central star is little more than a pale, ghostly, and cold glow, reside the most misunderstood and isolated worlds of all. Uranus and Neptune, the ice giants of our system, are not just smaller, colder versions of Jupiter. They possess a fundamentally different chemistry that places them in a chilling category of their own. The deepest and most beautiful secret of these worlds is that beneath their icy atmospheres, The pressure is so extreme that clouds of pure carbon compress until they become rains of solid diamonds, falling silently toward the core. Unlike the gas giants, which are almost entirely pure hydrogen and helium, ice giants are primarily composed of heavier, more complex, volatile materials, such as water, ammonia, and methane. Astronomers call these materials ices in astrophysical terms, though in reality, they exist as dense, hot, and supercritical fluids. It is the methane in the upper atmosphere that absorbs red light, giving these distant worlds their distinct, haunting teal and azure colors that we see in NASA's photographs. Uranus is the true eccentric of the group, orbiting the Sun, lying down on its side, possibly the result of a colossal, world-shattering collision early in its history that scrambled its magnetic field in its ring system. Neptune, on the other hand, is home to the fastest, most violent winds ever recorded in the solar system, whipping its atmosphere at supersonic speeds, driven by a mysterious, hidden internal heat that Uranus strangely lacks. These worlds are nature's ultimate high-pressure physics laboratories. Their magnetic fields are complex, strangely misaligned, and highly unstable. They are the lonely guardians of the final frontier before the vast interstellar void, worlds of perpetual blue and absolute cold, where the chemistry of water and carbon creates phenomena that defy our human imagination. An ice giant is a static, serene beauty on the outside, hiding a chaotic heart of pressure and falling diamonds within its deep, dark interior. Number 5. Lava planets. Imagine a place where the very ground you step on is a churning ocean of molten stone, and the sky above literally rains liquid rock. In distant, crowded solar systems, there are worlds that orbit their parent stars so closely that they complete an entire year in just a few short hours, spinning in a desperate, suicidal dance with stellar fire. In these lava planets, the face facing the sun is an eternal mirror of bubbling magma, where the temperature is high enough to vaporize solid iron and turn silicon into a thick, suffocating gas. These worlds, such as the infernal Coro T7b or the extreme K2141b, are the direct geological result of unbearable stellar proximity. Due to colossal tidal forces that act as permanent gravitational anchors, they are tidally locked, always showing the same burning face to their star, while the other side remains trapped in eternal freezing darkness. While the day side is a constant, glowing liquid cauldron, the night side can be frigid enough to freeze air, creating a thermal contrast that generates supersonic winds of truly apocalyptic proportions. In these screaming gales, vaporized rock from the hot side travels to the cold side, where it quickly condenses and falls as stone snow or granite rain, a bizarre geological cycle that completely replaces the water cycle we have here on Earth. Studying a lava planet is like having a front row seat to the violent, fiery birth of Earth itself in slow motion, long before our own crust had the chance to cool. They possess atmospheres composed of mineral vapor and magma oceans that can be hundreds of miles deep, hiding metallic cores that seem to be in constant agony. For scientists, these worlds are laboratories of extreme physics, revealing how matter behaves under intense and constant electromagnetic radiation. They remind us that in the vastness of the universe, the line between a solid, rocky planet and a small, burning star can be hauntingly thin. A lava planet is the ultimate testimony that geology can be as fluid, as terrifying, and as destructive as the original fire of creation. Number 4. Ocean worlds. In our own system, water is a precious and scarce resource that covers the surface of the Earth like a thin and delicate film of life. But in the vastness of the galaxy, there are planets where water is not just a decorative detail, it is the absolute totality of existence. Ocean worlds are spheres where not a single inch of dry land exists. Only an infinite blue abyss that can be thousands of miles deep, hiding mysteries that defy all known laws of terrestrial biology. These planets generally form in the cold, outer regions of a planetary system, and then, due to complex gravitational interactions, migrate closer to their host star. During this long, epic interstellar journey, the accumulated ice melts, creating a global ocean with no shores, no continents, and no accessible bottoms. Unlike Earth, where the seabed is composed of volcanic rock, in a true ocean world, the pressure in the abyssal depths is so overwhelming that water is physically compressed into an exotic form of crystalline ice called Ice 7. This ice is not cold to the touch. It is a solid, dense, and hot barrier that separates the liquid ocean from the deep rocky core, which often prevents the crucial exchange of minerals essential for life. However, icy moons like Europa and Enceladus suggest that worlds with internal oceans may be our very best targets for finding extraterrestrial life. In these specific locations, the heat comes from the core and the water directly touches the rock, creating a chemical soup rich in nutrients and thermal energy. An ocean world is a realm of absolute silence and infinite heavy pressure, where sunlight never reaches the lower layers and where the very definition of sea is taken to a terrifying planetary scale. They are the great potential reserves of life in the cosmos, simply waiting for our robotic probes to penetrate their layers of mystery and discover what might be swimming in that eternal sunless darkness. Number 3. Carbon planets. What if, instead of being made of silicate and oxygen rocks like our Earth, an entire planet was forged from a metallic abundance of carbon? In systems where carbon chemically outweighs oxygen, the entire recipe for life and geology is completely inverted, creating landscapes that look like they came straight out of a science fiction fever dream. In these alien worlds, the mountains are not made of granite or limestone, but of pure, dark, shimmering graphite, and the depths of the crust hide layers miles thick, composed entirely of solid, sparkling diamond. A carbon planet is a visually dark, brooding, and opaque place. The surface would be covered in a thick, sticky mixture of tar, soot, and black hydrocarbons, with viscous oceans of oil or liquid methane shimmering under the dim, filtered starlight. The atmosphere would be dense, heavy, and perpetually laden with smoke and toxic cyanide compounds, making it instantly deadly to any form of life we currently know. However, for a future technological civilization, these worlds would be mines of unimaginable treasure. Places where gemstones we consider rare and expensive on Earth are as common and mundane as quartz sand on a tropical beach. The geology of these planets would be both bizarre and fascinating. Imagine volcanoes that spit out diamonds in high-pressure eruptions and skies that glow with the black reflection of crystallized graphite. Carbon is the basic element of all organic life, but in these extreme and pure concentrations, it creates a hostile, metallic environment that is utterly strange to the touch. They prove definitively that the recipe for a planet depends entirely on the specific chemical ingredients left behind by the explosion of the star that preceded it. A world made of diamonds sounds like a paradise for an explorer, but its physical reality is a black desert of crushing pressure, intense internal heat, and impenetrable, soot-filled darkness. Number 2. Rogue planets. Most of the planets we know are tied to a star, condemned to rotate eternally around a single source of light and heat. However, hidden in the shadows of deep space, there are worlds that were violently expelled from their homes and now wander lonely and silent through the interstellar void. Rogue planets are cosmic nomads that do not orbit any sun, traveling in total darkness at incredible speeds. And it is estimated that there are actually more of them in the void than there are stars in our own galaxy. These planets usually begin their existence in normal solar systems, but they are aramicetos, thrown into the void due to gravitational fights with larger planets or neighboring stars. Without a sun to warm them, their surfaces become deserts of absolute bone-chilling ice, where the atmosphere itself can eventually freeze and fall to the ground like solid snow. However, the outer appearance of death can be very deceptive. Thanks to the slow radioactive decay in their cores and the thermal insulation of thick ice layers, many rogue planets can actually maintain internal oceans of liquid water for billions of years. In these dark abysses, far from the light of any star, life could theoretically flourish around hydrothermal vents, evolving in a world that has no concept of day, night, or the passing of seasons. They are almost impossible to detect because they emit no light of their own, being revealed only when their massive gravity briefly distorts the light of distant stars. A phenomenon called gravitational microlensing. Each rogue planet is a drifting time capsule of a solar system that rejected it long ago, carrying geological secrets across the vast, lonely distances between the constellations. They are the ghosts of the universe, silent reminders that space is a violent place where entire worlds can be exiles. Wandering through one of these worlds would be the loneliest experience imaginable, looking at a sky where the stars never change position, in a winter that will never, ever end. Number 1. Planets that shouldn't exist. As we explore the deeper reaches of the cosmos, we find worlds that defy all our known laws of physics and our most cherished theories of planetary formation, acting as if the rules of the universe were mere suggestions. These are the impossible planets, true space anomalies that force astronomers to rip up their textbooks and start again from scratch. Whether it is a world that orbits a dead star that should have incinerated it, or a gas giant orbiting so close to its sun that its atmosphere defies the laws of evaporation, these worlds prove that reality is much, much stranger than our imagination. A classic example is the planet Kepler 70b, which somehow survived the red giant phase of its star, literally passing through the solar fire and emerging on the other side as a charred, defiant survivor. Another is the Cotton Candy Planet, worlds the size of Jupiter, but with the density of a marshmallow, something that current physics has immense difficulty explaining. How does it maintain its cohesive without simply collapsing or dissipating into space? There are even worlds orbiting pulsars, collapsed neutron stars, that emit radiation so lethal that the mere existence of a planet around them seems like a mathematical error of nature. These anomalies exist because the universe operates on timescales and under physical conditions that we are only just beginning to understand. They may be the result of highly unlikely collisions, bizarre gravitational captures, or chemical processes that we have not yet been able to replicate in our computer models. Each planet that shouldn't exist is actually a portal to a brand new type of physics. They are the rebels of the cosmos, the bugs in the system that show us that the impossible happens every single day. In the end, they teach us the humblest of lessons. The universe has no obligation to make sense to us at all. And these are just the types we know about today. Because out there, in the vast, unexplored reaches of space, there may be worlds even stranger than anything we've discovered so far. If you want to keep exploring the mysteries of the universe with me, then definitely watch the next video appearing on your screen right now. The world is full of hidden stories, and here at Paint Facts, we reveal the most impressive ones. So subscribe to the channel and turn on notifications, because the next fact might just surprise you.